we actually start with the meeting. Okay. Don't worry about that. And now I will make you the host, and I will leave after that. If I can join back again, I will join, but you will still be the host. Is that okay?
Sounds good. Let me verify that I've got host settings.
No, I will make you now.
Great.
Okay, now you are the host. You have superpowers, Joe.
All right, I will share the agenda. Thank you, Fede.
Thank you so much.
All right. Thanks everybody for joining today. We are going to have our April 3rd edition of the SIG API Machinery semi-weekly meetings. This follows the typical code of conduct for Kubernetes. I'm going to share the agenda now, and we're going to get started. All right, can everybody see the agenda? All right, we're just going to go ahead and get started. So our first item from Harish Kuna, we have a question about optimizing etcd. Harish, are you here?
Yeah, I'm here.
Great. Would you like to introduce this?
Yeah, sure. So basically on etcd, I think there is a proposal which is in that this particular link.
Okay.
So it's optimizing the range queries on their end has a really good performance impact on the etcd front, which will translate to the the clients for the API server clients, right? For, in terms of the latencies. So I just wanted to know if the community is open towards this. Basically, I think the etcd at this point, the maintainers is if the API server community is particularly okay, its community is open to this, they would go ahead and implement on their end. So I was just wondering if you guys have any thoughts around this. If so, if you are all agree on this, basically I can go ahead and write a cap for this from the API server side, or at least drive that discussion.
Great. Yeah, thank you for opening this and digging in. So my rough take on it, if I read the data right, was that even if you put a limit, and I think the limit here was set to 2, even if you set a very small limit on the number of objects that you actually want back from etcd, when you're non-optimized, the cost continues to go up based on the number of objects that match the full request beyond that limit. But then when you're optimized, you end up with a much more closer to a fixed cost here. And this is because you are now no longer returning, you're no longer counting the size, which requires additional processing. And so if I understood right, the gap was the etcd side would need some way to continue to return a count, and the plan would be to do that.
So to make it backwards compatible, they wanted to send the count, but they also wanted to see if we can from the API server side, if we can rely on not sending the count from the etcd itself. So there is some ways to get around this. Is from the API server is sending a list call to this, and the first part of the list page, the pagenator list call, will get the count back, but there will be another field that gets introduced, is what in this proposal they're saying is the no count field for the subsequent paginated calls, where because anyway we get the count from the first call, so we can use that to use the to calculate the remaining item count that we actually send it to the clients today, and encode that in the continue struct is the idea. But
Right. Yeah, encoding it into the continue, the token is opaque today. That seems plausible. I'm trying to think if there's any obvious problems with putting more information in the continue token. I agree that the initial call is going to need it, and that it only works if you're able to continue with an exact token, right? And then you could chain it through. That seems reasonable to me. I'm curious what other people think, or if there are other questions. If there's not, I would just move forward with making sure that everybody understands that that's the specific proposal. So maybe add a couple notes here saying that like the proposal is to add this to the continue token, verify that seems to be possible. And then, yeah, this I think would require a cap on the Kubernetes side because it does touch the API, but it wouldn't need to be a particularly long one.
Yeah. Yeah, I can get that cap going. Yeah. So, but we have done a POC like internally, and then
Okay.
like at least the POC seemed fine, like from the API server point of view. So.
Okay. Yeah. I mean, thank you for the optimization. I love to see anything that this is going to not only make things faster, but presumably reduce some load on etcd, particularly in certain cases like startup.
Cool. Thank you.
Great. All right. Were there any other questions for that one before we move on? Okay. Next up, we have Sony Song. We have quota with scope for volume attribute class. I believe I have this one open up. Is that it? Wait, nope, that's the previous one. And add quota support. Yes. Sunny, are you here? All right. If not, I think this is just a call for attention on this proposed change. The idea here is that we are adding resource quota on a per volume attribute class level. It's a little different than most resource quotas in that it's measured against the relationship between objects, right? So every time, I don't know if everybody's familiar with storage here, but every time you have a persistent volume claim, it has a class. It has a field that specifies what class it is, and this is going to count how many PVCs can use a particular class. So that's the relationship. Okay. Is there anybody here that wanted to talk about that or bring up any more details? Otherwise, I'm going to just assume that as a call out. All right. Next up, we have Jeffrey with coordinated leader election. Jeffrey, are you here?
Oh, yeah. Hello.
All right.
Yeah, do you want to just click into the enhancement?
Sure.
Yes. So I just briefly wanted to talk about this cap and just, I guess, bring some more awareness. So the current leader election mechanism in Kubernetes works in a way such that components such as kube controller manager, kube scheduler, etc. Race for release to determine a leader. And this is fine for most scenarios, but specifically in HA cluster upgrades and like rollbacks, where clusters could have mixed version API servers, controllers, and etc. The leaders and the version of the different components, such as a controller manager, could be in a sort of mixed state, and it's not really deterministic, sort of which version would get the leader, and this sort of breaks the Kubernetes version skew policy, where a controller manager or any leader elected component must not be newer than the API server. And so we're introducing this thing called coordinated leader election, which we want to facilitate safer upgrades in HA clusters by centralizing the lease assignment for leader elected components, such that instead of racing, these leader elected components do not directly try to acquire the lease, but instead are assigned a lease by a centralized component, which we call the coordinated leader election controller. And this works in conjunction with the introduction of component identity leases, in which instead of sort of directly trying to fetch a lease, the components would advertise their availability through this component identity lease. And then the leader election controller is responsible for actually assigning and picking the best leader out of all the available candidates. And one additional thing this introduces is it allows sort of preemption in that the leader election controller can send a signal to a component such that the component can give up the lease through this end of term marker. and allow for a more suitable candidate to be selected. And obviously, there's a lot more to this CAP that I won't go through in full detail. But I guess for the purpose of this meeting, I think I'm just looking for two things. One is just general feedback on for this CAP, and we propose to place a leader election controller in the API server. So if there's any thoughts on that. And number two is extensibility. So our goal is to target specifically HA cluster upgrades and fix this version skew problem. But also, like, if the algorithm is configurable, we could have additional use cases. And I'd just like to learn if I guess the community would have like different sort of preferences for these algorithms. Yeah.
Great, thanks, Jeffrey. Fair disclosure, I'm also a co-author on this one, so I am also looking for feedback. If anybody needs access to the link, it is here in the meeting notes. Does anybody have questions, thoughts on a different approach to leader election?
I was going to ask, was there any consideration given on making it easier for implementing leader election by just having nodes act out that leader leaseholding? Like, there's a lot of controllers that are just basically using the client code. That's great. Are there advantages to, since we already have node leases and the kubelet already has to manage some of this, is there any value, maybe later on down the road, maybe early, did you explicitly consider deny it to say the pod itself holds the lease and the kubelet can enforce shutdown in those scenarios?
So this was almost entirely focused on controller leader election. So the idea of like having like, 3 KCMs or 3 cloud controllers. Nodes, we didn't think this was such a good fit for, because this is less about announcing presence and more about picking a leader from multiple candidates.
And I'll note, I think that the general pattern is that you want controllers not to have to be coupled to a Kubernetes controller or to a cluster. Like, there's better security properties of it. But in practice, the vast majority of poorly written controllers in the world using our libraries are running on top of clusters as pods. Are there aspects that
I see what you're saying.
Others might benefit? Because at some level, I think this is a better approach just from a coupling perspective. But we always did. There have been requests over the years for things like if the pod hasn't been able to contact the API server for a certain amount of time, terminate it, which is effectively a form of election. It's not election. It's a form of holding a distributed lock. And there are other use cases for pods and leader support that would make things like replica deployments or stateful sets better able to accomplish their purpose. I think it's probably more of a follow-up.
Yeah, I think it's really interesting. Yeah, I hadn't actually thought of this. I think probably the reason I hadn't thought of it is I was mostly focusing on the use case where you have like static pods in the control plane. But yeah, if in the case where you do have stuff running in the data plane, that's really interesting. I would like to follow up on that and think more about it.
I think you've picked the right coupling, because the thought of forcing people, like, we should never force people to have to run controllers on a cluster to get the right behavior. That would be very, very wrong. So whatever we do needs to be improved, and I think this is in that path. There are a lot of use cases where it would be much more efficient for a large class of workloads if the permission to keep running, either as an instance out of a set or through, the kubelet has to check. The kubelet's maintaining a lease with the API server anyway, where you would, who's the best? KubeVirt. Effectively, like almost every VM system also has a distributed lock service because VMs expect to be singletons, pods don't. Maybe this is just a later on down the road after you've proven this out, there may be some design points that could be relevant for them. For workloads that need exclusion for other reasons than controller leader.
I think that's really interesting, just the more general idea of exclusion. One thing that we did think about a little bit when we were, it's kind of related to that in this KEP was, should we put most of the logic that manages the leader election in the client, or should we consolidate that into a little tiny controller that manages the elections as part of core Kubernetes? And since this was a slightly more complicated leader election algorithm and it requires more knowledge of state, our current proposal is to have a very small election controller that runs and sees all the candidates and then picks a candidate, rather than having all of the candidates realize each other's presence and try and coordinate that like you might do in a consensus algorithm for a distributed data system. So that's a slight difference.
There's some definite operational risks there. Blast radius is higher, but ability to roll out fixes is better.
Yeah. And so that's kind of why we favored that, was the ability to roll out fixes. But that there is a trade-off there, and we acknowledge that.
I think, just to go back to like one of the original things that we didn't talk about a lot in the early days, but was always kind of in the back of the mind in that early API machinery, was the novel property of etcd is that it is providing strong, distributed, resilient HA. Like no other database has come close to providing that in the open, even in 10 years. And the characteristics of locks and leader election is pretty important. So I certainly think the role of Kubernetes providing primitives for correct distributed system behavior kind of is a good argument for taking some of the complexity off the clients. And both of the things I mentioned, or what you mentioned and what I was mentioning, I think are both variations of that same principle.
Yeah, I agree with that. Any other questions, thoughts? I think this will be a good one to follow up on. Jeffrey, did you get everything that you needed out of this?
Yeah, I'll follow up on this next time.
Okay. Yeah. Thanks for bringing this up. Appreciate seeing activity on this. All right, Clayton, you're up next.
All right. Thank you very much. So I am. I'll put the link in the notes. We sent an email around to a bunch of SIGs about the proposal to form a working group on serving. And by serving, there's a slight bias in that. There's a lot of people who are running increasingly large amounts of machine learning inference on Kubernetes. That's been going on for a long time. Large language models are kind of interesting because instead of building a platform, you tend to deploy them as deployment artifacts. So, large language models tend to look a little bit more like regular web apps than they do look like microservices. And so one of the bits of input that folks have been bringing up was that Kube doesn't really focus on that. So we're kind of calling inference maybe the fourth major workload type. We had microservices and services, we had stateful workloads, we had batch, and I think there's an argument that, and you could argue maybe there's a fourth, which is frameworks running on top of Kube, controllers, operators, things like Ray or Slurm that use Kube as orchestrators that themselves use Kube to orchestrate some portion of workload. Inference being that fifth category. And some of the challenges there are like the primary sponsor is going to be SIG apps, but out of all of the use cases, one of the things that we were kind of thinking, and Joe and I had a brief discussion, not as much of this is captured, is there's two projects in the ecosystem today that are controllers around inference. There's Kserve, which started based around Knative, and they use the class construct to have a backend implementation like runtime class or like what Gateway's been doing. But the interesting thing is in in Kserve, that choice of serving class is kind of a model server, but a model server is this big chunky thing that you need to parameterize pretty deeply. And some of the limitations around classes and CRDs have shown up for Kserve, or for Kserve. There's another project from the Azure team called Kaito, and they have presets or they have pod templates. And presets are map string and a name for the preset for parameters. And if that doesn't work for you, or if you need more structure than that, well, too bad, you got to go use a pod template. And I'm oversimplifying for maybe comedic effect, but in talking with Joe and talking with a few others, Adullah, who did a lot of work on job sets, one of the things that we were noticing was that there is room for CRDs to get better when a chunk of what the CRD does is exposing behavior from others. And we've endorsed a few patterns in API Machinery over the years, create sub-objects. Gateway kind of push the boundaries of this. They have a number of extension points. One of the things that was coming up, talking through people who kind of wanted pre-canned, and this has come up a ton in operators, like almost every operator does some variation of one of these when they hit this problem. None of the solutions are particularly great. So the idea of, there's going to be these model servers, there's maybe not a billion of them, there's maybe a couple hundred, and everybody might kind of have their special one, but they want to benefit from shared orchestration, has kind of led to a couple of ideas around what can we do to improve CRDs? What can we do to specifically try things that are more of the controller's problem? Maybe prototype some ideas with some of the ecosystem groups like Kserve or Kaito, as well as try to actually make it so that people coming to Kubernetes out of the box don't have to know some of the Kubernetes details up front, but then later as they start saying, oh, well, I need to add this patch, or I want to change this bit of the controller. If everybody's going to be doing inference in 5 years' time, we're all going to be running LLMs on our own platforms, and the set of lower level components is fairly small, maybe in the tens to hundreds, but everybody might have their own variation. That's kind of a new pattern, maybe not a new pattern, but it points to problems that Helms typically had. If you want to change a Helm chart, now you own that Helm chart now if you've added one parameter. So the idea might be when we add CRDs at the high level, how do we keep the extensibility and the simplicity at the high level, but allow individual users or organizations to take most of the work that works really well for that core controller and change a few things, whether that's at deployment time, right? Small patches to the output, or having much more complex implementations. It's not easy today to fork controllers. For a long time, we said, hey, if you don't like HPA, you could fork it. The number of people in the world who forked HPA and felt good about that afterwards is pretty low. So we have some challenges with extensibility there. So at least in the working group, one of the angles is going to be very much focused on something better than, not something, taking some of the lessons learned from Kserve, from other projects in the ecosystem that tried to use classes, and making forking and variation a little bit easier. And then we wanted to at least engage SIG API Machinery, in the next couple of months as we prototype. We wanted to bring some ideas. I ran a few by Joe, and he was giving me examples of other people who have requested it. So Cell also has come up multiple times where we want to think about using Cell in those areas. So that's kind of the specifics that might be relevant to API Machinery. But I think we would we're already starting to think, we'd really love to push the right boundaries for extensibility and controllers.
I think this is a great forcing function. When I hear the idea that people might have to basically copy paste all their infrastructure just to run an A/B test because it's just slightly too different, and so nothing can be propagated through. That seems to be a pretty good signal that we could do better.
And Yeah, I forgot to even bring that one up. I had a discussion at KubeConU at the rejects session. We were kind of talking gateway, and AB today is everybody goes and implements AB basically the same way across almost every. The first thing that a platform team picking Kubernetes for model serving does is they go build an AB mechanism to test deployments and to test rollouts safely. And so there were some examples there of, Kube is great because you can easily take a declarative object and split it into two. But there is no primitive today that makes that easy. So that was another dimension. Maybe as part of this work, most inference needs AB because you don't know ahead of time whether the model's going to work. And so that's a great example, Joe, of another area that we might get at over the next 6 months or a year or so.
Yeah, I think this is great. I'm personally really interested in making sure that the API machinery keeps up on stuff like this. And I would love to get other people involved. So if people do have interest, please come talk to us. Please come join the future meetings. I'd like to keep bringing this up and try and make it concrete and figure out what we can do. I know there's a bunch of historical projects laying around that never got done. There's some ideas of different kinds of CRD extensions or sub-resources or enveloping that have been thrown around that may help. But I think this would be a really good forcing function to find some things and actually make real progress.
I think we'd love to be a guinea pig for API machinery improvements because we know that there's more than 5 and less than 1,000 variations that people are going to have. And I'd love to find a way that people don't have to repeat themselves. And today in Kubernetes, there's a lot of repeating yourself when you want to build something that fits alongside what's already there in Kubernetes.
Mm-hmm. Yeah. Okay. This makes a lot of sense. Are there any concrete next steps we should be thinking about now, or just start looking for people and joining in on the working group?
So we'll probably propose a charter in the next couple of weeks and then kick off first couple round of meetings. I'd like one of the first use case I list in the doc is very much the something better than serving classes in KServe, or thinking about how we could go beyond that. We don't need that for the first step, but that was my most pragmatic one. And then I think we'd love to on the AB side, once we get a sufficient set of people involved there, that one might take a little bit longer to get started. That would probably be maybe a follow-up or later this year, but I would invite people to participate or to follow along, and we'll try to generate good output, both in terms of use cases and projects, suggested projects that we could partner on, and we'll bring those back to the SIG when we do.
Okay, that sounds great. We got a question from David.
Is this stuff going to be in tree or out of tree like GUI API?
So the working groups generally would be out of tree to start with, and I think we've got KServe, which is owned by CNCF. Kaido is not either of those. There's a few other projects out there that people have done. I think part of the reason for creating the working group would be to have a place for us to experiment on common elements and potentially spawn exploration prototypes that would really push the boundaries here, maybe in the long run leading to a controller that would be in tree. But I don't think that that's a, Q and working group batch, for instance, or working group batch has sponsored a number of projects that are out of tree, like Q and JobSet, which are starting to see significant adoption. And the nice thing is we don't have to be in tree to hit those. So certainly when Joe and I were chatting, the idea of starting with something that's out of tree that could actually push the boundaries of controller-runtime, or experiment with feature branches, for instance, would be, I think, an opportunity as well.
Cool. Sounds good.
And it may not just be one thing. We very much want the working group to kind of have a couple of different tracks. there's a track to work with the DRA work, which is better resource model. There's probably a track on simplifying primitives for workloads, and there's probably a couple tracks on auto scaling and the kind of novel things you can do with hardware that CPUs never mattered for. So I'd probably say a couple tracks at least.
Other questions? All right. Anything else, Clayton? Anything else to add?
Nope. I appreciate the time, and if you have questions, hit me up on Slack. Thank you.
Yeah, thanks so much. That is it for our agenda today. Did anybody have any other quick topics they wanted to bring up? If not, we will finish it there. Thank you all so much, and we will see you again in 2 weeks.